So in this video, we're going to look at solving inequations. Now, the big difference between equations and inequations is the fact that equations have an equal sign in the middle and inequations have an inequality symbol. And these inequality symbols are your greater than, your less than, your greater than or equal to, and your less than or equal to symbols. So when you're reading an equation, remember you're reading it from left to right. So 5 is greater than 3 is true, but 5 is less than 3 is false. 5 is greater than or equal to 5 is true, and 5 is less than or equal to 5 is also true. So when you're substituting in values to check if your inequation works, make sure that you're reading it from left to right. So an inequation is a relation between two quantities that are not necessarily equal. So if I think about a number and I add 7 and the answer must be less than or equal to 10, I'm no longer thinking about setting up an equation, I'm thinking about setting up an inequation if I want to work out all the possible values of the number. So this problem involves solving the inequation x plus 7 is less than or equal to 10. Now, when we're solving inequations, we're using the same techniques as for solving equations. In other words, we're using our inverse operations. So if I've got x plus 7, my inverse operation is subtract 7. So I'm going to subtract 7 from both sides. That gives me x is less than or equal to 3. If I then try a number that's less than or equal to 3 to see if my original inequation works, if I do 0 plus 7, I get 7, and 7 is indeed less than or equal to 10. So my inequation is true for x is less than or equal to 3. So the other key piece of information to remember is that when an inequation is multiplied or divided by a negative quantity, the inequality symbol changes sign. So in other words, it flips around or it inverts. So it goes from being a less than sign to a greater than sign, or goes from being a greater than or equal to sign to a less than or equal to sign. Now, the other key piece of information or advice I would give you is that make sure that if it's an inequation, you keep using the inequality symbol as you're going down your working. It's a common mistake that people suddenly change to equal signs halfway through their calculations or put an equal sign in their final answer, and that would be an incorrect solution. So, the first example demonstrates this requirement to change the sign. We've got negative x is less than 2. Now we want to have a positive x in our solution, so we've got negative x. So we're going to have to divide both sides by negative 1. Now, negative x divided by negative 1 is going to give me the positive x term that I require, and 2 divided by negative 1 is going to give me negative 2. Now, if I was to put the less than sign in there, and leave it the same way round as it is in the original question. If I choose a value that's less than negative 2, for example, negative 10, if I substitute negative 10 into my original inequation, so I would have it negative 10, which is positive 10. And if I read it left to right, 10 is less than 2, that would be false, which is why I need to flip the sign around. And so my solution is x is greater than negative 2. So if I choose a value that's greater than negative 2, for example 0, 0 is less than 2 is a correct interpretation of that inequation. So I know that x is greater than negative 2 is the correct solution. Now, the other way of looking at it is if I rewrite this original equation as 2 is less than or even greater than negative x. If I add x to both sides, I'm going to get x plus 2 is greater than 0. If I then take away negative 2 from both sides, I'm going to get x is greater than negative 2. And you can see that I've solved it in a slightly different way, but I've ended up with exactly the same solution. So the next example, I've got 2x take away 5 is greater than 7x take away 3. Now, when we're using the same techniques as solving equations, we're gathering all of our variables onto the left-hand side and all of our constants onto the right-hand side, and then isolating x. Now, because I've got a larger number of x's on the right-hand side of my equation, I'm actually going to rewrite this for my first step so that I don't have to worry about having negative x's in my final stage of my working out when I'm isolating x. So I've got 7x take away 3 is less than 2x take away 5. Now, the first thing I want to do is I want to collect my constant terms onto the right-hand side. So I need to do the inverse of take away 3. So I'm going to add 3 to both sides. And that gives me 7x is less than 2x take away 2. Now I want to collect my variables onto the left-hand side. So I'm going to take away 2x from both sides. And that gives me 5x is less than negative 2. And then the final step is to divide both sides by 5. And so my final answer is going to be x is less than negative 2/5. Or I could write it as negative 0.4, but leaving it as a fraction is a valid solution. So then if I want to try a value that's less than negative 2/5, I can try a value of negative 10, substitute that in. If I have 2 times negative 10 is negative 20, take away 5 is negative 25. And if I have 7 times negative 10, that's negative 70, take away 3 is negative 73. Negative 25 is greater than negative 73, so I know that my inequality and my inequality symbol is the correct way around. So my third example, I've got 8x plus 3 is less than or equal to negative x plus 12. So my larger number of x's is already on my left-hand side, so I'm just going to start collecting my like terms. So I've got a plus 3, so the inverse operation is take away 3. So I'm going to take away 3 from both sides, and that gives me 8x is less than or equal to negative x plus 9. I then need to collect my variables, so I'm going to add x onto both sides, and that gives me 9x is less than or equal to 9. And my final step is to divide both sides by 9. And so that gives me x is less than or equal to 1. So let's try a value. 0 is less than 1, so 0 plus 3 gives me 3 on the left-hand side. And we're saying that 3 is less than or equal to 0 plus 12 is 12, and that's true. So therefore, my solution to this example is x is less than or equal to 1. Final example, we've got 20 take away 2 upon 3x plus 8 is greater than or equal to 8 minus 5x. So before we can start solving this inequation, we need to expand that bracket and collect the like terms on the left-hand side. So we've got 20 take away, and we've got negative 2 multiplied by 3x is 6x, and negative 2 multiplied by 8 gives us negative 16, and that's going to be greater than or equal to 8 minus 5x. Then we're going to collect our like terms together, so we're going to end up with negative 6x plus 4 is greater than or equal to 8 minus 5x. So now we need to collect our constant terms, so we're going to take away 4 from both sides. So we've got negative 6x is greater than or equal to 4 minus 5x. We want to collect our variables onto the left-hand side, so we're going to add 5x to both sides. So we're going to have negative x is greater than or equal to 4. Now remember, we need a positive x term, so we're going to divide by negative 1. And remember, we have to remember to change the sign, so it's x is less than or equal to negative 4. And we could try some values and substitute it in order to make sure that our x is less than or equal to negative 4 solution is true.